Okay, so today we are going to be talking about error handling. So we are going to take our application that we looked at and built last week and add some error handling to it. Error handling is usually an afterthought for a lot of developers, but at Hack for Impact, we try to design our systems with users running into errors in mind, which lets us easily add error handling when we're ready without having to make major code changes and kind of change the structure of our code. So while we don't like necessarily implement the error handling itself right off the bat, we do design it with like, okay, there's going to be a place for error handling here in the future. So we're going to go ahead and take a look at how we do that and some of the practices we use here at Hack for Impact. But before we actually talk about the errors we'll run into and how to handle them, first we need to understand HTTP status codes, okay? If you haven't heard the term before, an HTTP status code is a 3-digit number that the server returns back with a response that indicates to the client the status of whatever the client tried to do. Okay. These status codes are broken up by like their first digit. So the first digit of a status code indicates a different kind of status. And we're going to look at 3 today that are the 3 main classes of status codes that are most useful and you'll run into the most in your web dev career. So the first set are those starting with a 2, okay? A status code that starts with a 2 indicates that the request was successfully handled with no errors, all right? The most basic one that you might have seen before is a 200 OK status, which is a just generic success status code. So the specific meaning of this code is dependent on the request. But for example, a 200 response on a GET request to a server essentially means that the data from the server that you were trying to get was successfully fetched and returned. Okay. Another important one that I want to talk to you about is the 201 status code, 201 created, you might see it as. This is a status code that you're often going to return from post requests that indicates the data that you wanted to create was successfully created, right? So in the application last week, we created a volunteer, and then the status code that we would return back from that like create volunteer request would be 201 created. And this just lets the client know that the data they were trying to create was created. All right. I'm not going to go over the rest of the status codes, but if I go ahead and Google HTTP status codes up here, the first thing that you'll see is this MDN web docs page right here. If you click on this, this actually has a list of all the most useful status codes. So if you ever see a status code, you don't know what it does, you can just look up the status code or look up this list, and then you'll be able to see exactly what it does and what it means. Okay. Okay, so the next set of status codes I want to go over start with a 4. Okay, status codes starting with a 4 indicate that there was an error, but this error was the client's fault. Okay, again, the most basic one here is 400, and that's a bad request status code, which essentially means that the server could not process the request successfully due to some error caused by the client, right? This is just a generic bad request, client messed up error. Status code. So one example of this happening would be if I hit our API endpoint to create a volunteer, but I actually didn't give it any data, so it like cannot create the volunteer. That would be a 400 status code because this was the client's fault. The client didn't actually supply that data to the server so that they could make the make the volunteer. All right. Another one that we use a lot and that you've probably heard of is 404, the not found status code. This is primarily used when looking up something on the server that doesn't exist. So for example, if I go into our app here that we built last week and I try and access a route that we didn't define, like let's just say bad route. And when I go ahead and load that, it's going to say, hey, 404, this page could not be found. So it gives me back that 404 status code, right? Again, there are a couple more that you might come across, but using the MDN documentation, you should be able to figure out what each one does. Okay, so that's 2XX and 4XX. The last class of errors start with a 500 or a 5. These status codes also indicate that there was an error, but this time it was the server's fault. The most basic code in this class is the 500 status code, which indicates an internal server error. Again, this is just like a generic hey, there's something happened bad in the server. An example of this happening is maybe let's say your database is down and your server cannot actually communicate with the database. That would just be like a 500 error because the client might have done everything okay. The database was down, so the client or the server couldn't process that request successfully. So, hey, that's 500. That's my bad as the server. Send that back to the client. And that's essentially all with that one. We use these error codes, the 500s, when we have caught an error that we weren't expecting to catch. So the 500 internal server error can also be thought of as like a catch-all error. If there's some sort of error that you're not handling, you would return a 500 and then try and figure out what caused that error so you could give a more specific status code. Okay. And the 500 internal server error is pretty much the only 5XX status code that we use. But if you're curious, you can definitely read the docs. There's some other ones, but we don't really use those. Okay. Any questions about status codes, the classes I went over, what they mean? All right, cool. Okay, so switching gears a little bit. The big topic today is validating our data, making sure it's in the right format and structure, and making sure all of the values are valid. This can also include things like enforcing that a number has to be positive or a string has some maximum length. And there are also some security implications here. If we validate our data, it's harder for a hacker to come in with some data we're not expecting and mess up our system or compromise our data, right? So TypeScript gives us some of this functionality built in, right? You know, we can define those interfaces and specify the data types of variables. And by doing this, the programs we write generally are always going to be in the format we expect, but this only works in isolation, okay? My TypeScript code will make sure everything is right on my computer. It won't let me do things like set a string equal to a number. But what if another computer sends me some data? How do I know that the data that they sent is in the right format and valid? In that case, we have to actually manually check to make sure that the data that they sent is good and we can work with it. All right. So because different systems might be speaking different languages, so to speak, we have to do this validation whenever we cross something called an application boundary or a network boundary. So for example, whenever system A talks to system B needs to check to make sure that system A sent all the proper data and it all looks good. Okay. In our projects, there are two major application boundaries that we deal with, and we've actually been looking at them for the past few weeks. We just haven't called out that those are the boundaries. So I'm going to show you guys an image here. Let's see. Here we go. Boom. Oh, I need to zoom out of this a little bit. There we go. Okay. So this, let me keep going. To recap, the workflow that we've covered in the past is 1, the client talks to the server via an API. So the client talks to the server via this API. 2, then the server talks to the database via Mongoose. And then 3, the server will get a response from the database, and then it'll send a response to the client, okay? The two application boundaries that we're dealing with are between the client and the server, or are between the client and the server and the database. And that's denoted by these dotted lines right here, okay? Like we covered a few weeks ago in our, last week in our, 2 weeks ago in our lesson about APIs, the API dictates what the client can and cannot do. So if you remember the restaurant analogy, the waiter or the API will make sure the customer or the client orders something that is on the menu. In a sense, the API validates the client request, and that happens after we cross the boundary between client and server. So right here, this API is kind of validating our request, making sure it's all good before it actually hits the server, okay? For example, Yeah, so the client and the server are two separate systems running on two different machines, right? And that's a good way to think about this, right? Your client is on your computer, server is somewhere else on a different computer. So for example, the server could be expecting the client to send over a number, like maybe an age value for a database. But theoretically, nothing would stop the client from sending, say, the entirety of the hit movie Happy Gilmore starring Adam Sandler. If the API doesn't validate that the client is sending a number, it might accidentally store that several gigabyte large blockbuster hit in the database instead of a single number like we intended. This could cause some real issues, right? So to prevent that, we just validate that what is sent across the application boundary to the server is a number, and we're all good. Then we can't send that movie, right? The server and the database are also two separate applications. And because of this, we also need to validate what is going to be put in the database to make sure it is in the right format before we do that. So if somehow the API was fooled and it accepted Happy Gilmore starring Adam Sandler, and the server tried to store it in the database, by validating the format of what we attempt to, sorry, excuse me, I got lost. By validating the format of what we attempt to send across the boundary, we'd be able to catch the mistake and prevent that hit blockbuster from going in, right? Lucky for us, we don't have to worry about the validation between the database and the server, because Mongoose acts as the validator, right? It acts as a layer between our server and our database. It won't let us store, Mongoose won't let us store bad data in the database. And if something messes up with the database, it won't give back bad data to the server. Is that sounding good so far? Okay. So that's great. But for the client and API boundary, we need to use something else. We need to manually build this, and we can use something called Zod for our validation, which we're going to talk about in just a minute. Okay. So just to sum all that up, anytime we cross an application boundary, we should be validating what was sent across the boundary. This is a good rule of thumb for any system. But in our case, it would look something like, one, the client sends the data to the API. And again, since we just crossed a boundary, the API validates that what the client sent is good and we're expecting it. Two, the API then passes the data along to the server. And since the API is actually part of the server, technically, they're running on the same machine, the server does not need to validate what it's getting from the API. Then the server sends the data to the database. And again, sending data to the database, that's a separate system. We're crossing a boundary. We need to validate that what we are putting in is valid. Mongoose does that for us, so it happens behind the scenes. And then later on down the line, the database sends data to the server. Since we crossed a boundary, Mongoose will again validate that what it got back from the database looks good before giving it to the server. And then finally, the server passes along the data to the API. No validation happens there. Server and API are on the same system. And then the API passes it along to the client. But since we just crossed that boundary again, the client needs to validate that the data it got back from the API is good and valid. Okay. So this is all well and good, but you're probably thinking, if we're the ones who code the client, server, and database, why do I need this validation? I know for a fact that my client will send valid data to the server. I'll make sure of it. And there's actually a few reasons that we ensure that we're doing validation everywhere. I'll talk about 4 of them. First, our applications are often public, so anyone can use them. So someone on our application doesn't have to use the client code we wrote to send data to the server, right? They could just manually hit the API endpoint and put whatever they want in there, even though our client, if you're using our client, that's only going to send good data, okay? By validating, we'll reduce the risk of some of these attacks on our system. 2, in a collaborative team environment, having validation rules in place can act as documentation that dictates how different parts of an application should interact with each other, right? So if I'm coding the back end of an application, I might add a validation rule that says, hey, this field should be a string that is 10 characters long, and I'll reject the input if it's not. Andrew can look at this code and figure out that his front-end code that he's writing should be sending the server a 10-character long string. This is a simple example, but as our projects get larger and larger, this becomes super important. And so that's another big reason that we'd like to do this validation. Third reason, if you're on the client, you might send a request to the server and it might fail, but you have no idea why. right? If we have validation rules in place, we can tell the client what was wrong with their request so they can fix it and try it again. This is overall a better user experience, but also it helps tremendously with developing and debugging our applications. All right. And finally, if you validate your data, you can make code changes with confidence. Okay. Let's say I no longer want to store a 10-character string in my database, but now I want to store a number. So I'll update my client to server validation, but maybe I forgot to change my server to database validation. With these validators, I know the exact format that my data should be in, so I could catch that bug pretty quickly before it causes more issues down the line that would be a lot harder to track down, right? Any questions about any of this so far? Does this all make sense? Okay. So before we move on, I want to actually take a look at why we need validation in our example application. So let's go over to it, and I'll go to the volunteers page. Give that a second to load. I'd load that in a new tab. Oh, dang it. I forgot to run my local Mongoose instance. Mongo instance. Give me 1 second. I had to reboot my computer right before this. We should be good now. There we go. Okay. So we're on the volunteers page. Let me go ahead and try and add a volunteer. So if you remember from last week, we said first name's required, last name required, email required, and phone number required. So what happens if I just give a first name and nothing else? Well, let's go ahead and submit and see. Okay, so it looks like that just went through. It looks like all is well, because if you remember from last week, when I submit a new volunteer, it'll take me to the volunteer list so I can see that volunteer. But if we actually scroll down here to the very bottom where it would show up, we see that that bad volunteer didn't actually get saved in our database. So as a user, I'm thinking, well, this just doesn't work. What happened? But as a developer, I can very easily see in here in this console for our server, oh, okay, phone is required, email is required. So they didn't supply those required fields, but the user has no way to know that. It looked like everything went well, and then it just didn't work. And that's a really, really frustrating user experience. All right. So that's just a quick illustrative example of why we need this. And we can actually see why this isn't caught. So if we go to the source/app/API/volunteer/route, you can see on line 5, if I hover over this data here, so this line is saying, hey, give me the data that's coming in from this request. If I hover over this, you'll see that this data type from TypeScript is any. Okay, that means TypeScript doesn't know what the data coming into our server is, and that data can look like anything. It can be anything. We have no idea. And so when we send this to our create volunteer, even though our create volunteer is saying, hey, I want to create volunteer request, since this type is any, it's like, that could be a create volunteer request. We don't know. We're just going to let you do that. And so TypeScript can't catch that. Okay. So in order to fix this issue and ensure that we're properly validating data across every boundary, at Hack for Impact, we use a tool called Zod. Now, Zod is just something we use at Hack for Impact. At like another web dev job, you may use something different. But the key idea here is that Zod lets us validate data coming across a boundary. Okay. So let's actually learn how to use it. In order to use Zod, the first thing you have to do is define all your types using a special variable that we import from Zod called Z. So let's take a look at how we can rewrite our volunteer type using Zod. So last week we created in our types folder, our source/types folder, we created this data model folder, and in here we put a volunteer.ts file. And so here is where we've defined our volunteer type. So let's go ahead and rewrite this type using Zod. So again, I said the first thing we need to do is import that Z. So I'll create the variable type Z and it'll automatically import. So let me go ahead and create a new variable for this Zod type. Export, okay, it's being a little slow. Export const Z volunteer. And this Z at the front means Zod volunteer. This is a Zod type. So at Hack for Impact, we just call all of our types that are built with Zod, the type name with Z at the start, right? And then I can say this is equal to Z, and it's going to pull up, okay, Zod. And then in here, I can actually use this type, or this variable. This variable has a lot of fields on it, a lot of functions on it. So I can use some of those functions to actually define what my type should look like with Zod. So the first thing I'm going to do is turn off Copilot because we don't want spoilers. Okay. First thing I'm going to do is say that, hey, this type we're defining is going to be an object, right? So this interface is an object. So we're going to say, hey, this is going to be an object. Okay. This is a function. So we call that function. And then inside of this function, we pass in the object that we're trying to define the type for. So we'll do the curly braces to say this is an object. And then in here, we're going to have all the same fields that this type up here has, but instead we're going to use other Zod functions to define what those fields types should be. Okay. So I can say first name is going to be z.string, and that's saying this is a Zod string. Then I can do the same thing with last name. Maybe I should have kept Copilot on so I wouldn't have to type all this out. Email, z.string, address. That's actually an optional string. So we're going to say z.string. And then after this function call, we can chain it with dot optional. And then finally, num events, which is just a z dot, not string, number. Boom. Okay. So that's looking pretty good already. But there's one more thing we want to do here. What if I passed a bunch of empty strings to my API request, right? We wouldn't want to allow that either, because then you're going to have a volunteer with nothing in it, right? So Zod actually also allows us to do a little bit of extra special stuff, making it even more powerful, where I can say, hey, this string, this first name string, it has to have a minimum length of 1. And I can do the same thing here, 1, min 1. And this is optional, so I won't say it has to be minimum length of 1. Okay, I think. Let me look at my example here. Yeah. Okay. On top of that, again, Zod is more powerful than TypeScript. Okay. Zod also lets us add what kind of string this should be. So in email, it's going to look very specific. It's going to have name at domain dot whatever, right? Zod actually lets us say that this type should be an email. So at the end here, I can say dot email. And so this whole email line right here, if I could spell. If I could spell, okay. This whole line right here is saying, okay, so the email, its type for Zod is going to be a string that is at least 1 character long, and it should be in the format of an email. All right. So let's recap what's going on here with the whole thing. First, we use a function called z.object that takes in an object to tell Zod that this type is going to be an object. Then we define each field we want in our type and use the z.string and z.number functions to define the type of each field. And we're also saying that our string fields can't just be empty strings. Okay. Then after that, we're saying the address is optional. We don't have to supply that. And we're also saying that this email field should be an email. It should look like an email, right? So this is great, but there's a problem with our current setup, right? It's going to be very prone to developer mistakes, okay? For example, let's say we want to start also tracking the age of a volunteer. So I want to come in here and I want to say, okay, we're also going to track their age. This is going to be a number. So right now we cannot use this Zod type as a TypeScript type because you'll notice this is a variable, right? So it's actually not a TypeScript type. So in order to update my TypeScript type, I also have to come up in here and say age number. I have to update it in 2 places. And this might not seem like a huge deal, but when you have a really large schema with a lot of different collections, you're gonna probably forget to update that in both places, right? It's gonna happen. I've personally had it happen to me more times than I care to admit. Luckily though, we can use our Zod type to define our TypeScript type, okay? So we can remove the need to actually define this type by defining a TypeScript type from our Zod type. So let's go ahead and take a look at how to do that. What we can do is we can come down here and we can say, okay, I want a new type. So this is saying this is going to be a TypeScript type. We'll just call this new volunteer for now. And what we're going to do is we're going to use another special function from Zod called z.infer. Okay. And if you guys have worked with generics, this is a generic function. So inside of this function, we need to say, okay, what type we're going to infer. So we're going to infer the Z volunteer type. And in order to do that, we can say type of Z volunteer. Okay. And so this is how we can create a TypeScript type from our Zod type. So we only need to define it in one place. We're way less likely to mess that up and cause bugs that we just shouldn't have had happen. And let's actually go ahead and verify that these are the same. So I'm gonna close that down. I'm gonna bring this down a little bit, and let's scroll up here. So I can hover over this type and see all the fields that it's got on it. So we have a first name, that's a string, last name, that's a string, email, that's a string, num events, that's a number, age, that's a number, address, that's a string or undefined. This bar here saying it's a string or it's undefined. And that's just what happens when you have like a question mark, when you have something optional. If it's not a string, it's going to be undefined because you don't define it. All right. And you'll see that is exactly the same as this type we've defined here, right? So we actually don't even need to write a type using TypeScript. We can just write it with Zod. So I'll go ahead and get rid of this. And if I go ahead and come in here and save that, everywhere in our application that used a volunteer, it's going to be able to do the exact same thing because the Zod type that we generated for TypeScript is the exact same as the old TypeScript type we had. Okay. So, oh, yes. What's up? Correct. Yes. So let's go ahead and take a look at an example. So right now this type has an age on it. I actually don't want the age. I'm gonna delete that. If I save this and I hover over it again, the age is gone. And so this is a TypeScript type we can use in our code for like normal TypeScript stuff. And we're getting it from this Zod type, which is very cool. All right. So one of the neat things about Zod is that you can create pretty much any TypeScript type in Zod and then call that z.infer function to get the correct TypeScript type. All right. So I'm going to go ahead and paste in some code that's going to convert the rest of our types in this file to use Zod. Boom. There we go. All right. So that is defining types with Zod and how we can do it. Any questions about any of this? Okay, cool. So now we've created our Zod types. We need to actually use them to validate our data across our boundary, right? To do this, we'll just go into that route.ts file we were in earlier. And we'll look at line 5. So line 5, this is where we're actually pulling the data out of our request. We don't know what type it is. We want to use Zod to say, hey, I want to make sure that this is that, what is it? That create volunteer type, whatever this is, right? I want to make sure the data looks like that, okay? So what we can do is under line 5, we will create a new variable. We'll call it validation result. Okay, and we're going to set this equal to z create volunteer request dot safe parse data. Okay, so if we come over to our volunteer type over here, you'll see we have this z create volunteer request, which is essentially the same thing as this volunteer type, except we omit, you'll see z volunteer dot omit num events. So as we talked about last week, we don't want to be able to create a volunteer with a bunch of events. Whenever we create it, they have 0 events, right? So all of our Zod types have this function on them called safe parse. And what this does is that it takes a variable and it checks if all the fields on it are the correct type and that no fields are missing, okay? If this check is successful, then this variable on it will have something called dot success. So we can say z validation result dot success. This variable right here, validation result dot success, will be true if there are no errors with it, and it'll be false if there are some errors with it, right? So after we validate here, let's go ahead and actually use this validation result to handle an error. So we'll say if not validation result dot success. So if our validation wasn't successful, we are going to use this next response dot JSON that we learned about last week to return an error response. So we'll do next response dot JSON. In here, this is going to be the actual data from the response. So I'll say, let's just give it like a error field, and we'll give an error message. So say invalid volunteer. And then the second argument here is the status. So we're going to use that status code stuff we learned about just a second ago. And anyone want to guess what the status is going to be on this? $400. So it's like 4 and then 2 other numbers. But yeah, exactly. Perfect. Great. So we're going to return back this error invalid volunteer with the status code 400 to say, hey, client, you messed up. All right. Okay, so that's the error handled. And now instead of calling create volunteer with data, which is again of type any, we can call it with this validation result dot data. And so you'll notice if we hover over the type of this data, you'll see it's actually the correct type. It's the exact same as what we're expecting in this create volunteer function. Okay, so doing this is just a personal preference of mine. You know, we've obviously, if we're here, if we're at this point on line 14, then the validation result on the data variable was successful. So we could just call it with data. That's not going to ever lead to any errors. I just like to be super safe with all my types by making sure that I'm passing the most narrow type possible into my function, Mike.
So what happens if you put the wrong status type?
The wrong. Oh, that's a good question. So the question is, what happens if we give back the wrong status code for a request? Well, not much. This is just a standard that people like to follow because it lets your client know what happened. It gives your client more information, and some browsers will do some special stuff around certain status codes. So you always want to make sure you're trying to give the most accurate status code possible. But it is just like a thing that's like, hey, everyone, try and follow this. Okay. Good question. All right. So any questions about using Zod to actually catch this error in the API and return an error if we gave it bad data? Cool. So we've got the API handle, but we're actually not doing anything in the front end, right? We're just sending the request and saying, good luck. So we actually need to catch the error and handle it in the front end so that we can display something to our users. So to do this, I'm going to go to the new volunteer view that we were working in last week, and we're going to look at this handle submit function. So as you can see, again, we're saying, hey, go ahead and send your data, and then we don't really care what happens, right? So we're going to start caring what happens. We're going to say, first, we're going to take the result of this fetch call, which is going to be a response back from the server. So we'll say const res, which is a response. And then what we can do after we have this response variable is we can actually check if res.status code or status is not equal to something that we want it to be. So if we look at our API over here, we see that, okay, when everything was successful, we returned something good. We get status 201. Okay, so that means everything was good. We created our volunteer. So we're gonna say in here, if my status is not equal to 201, something probably went wrong and we want to display a message to the user. All right. So what we can do is first we'll define a new variable called data. This is going to be the response data, right? And we'll say that is equal to await response.json, right? So just like when we made our request, we had to say, hey, get my request.json. Now we're saying, hey, get my response.json. And the response data, again, is going to be the first thing that you pass into the next response.json here, okay? So then after we have this data, you would probably want to do something a little fancier, but I'm just going to right now use this alert function and say failed to create volunteer. And then I'm going to use that string interpolation we talked about weeks ago to then put in my data.error, right? Because if we get an error back, you can see we are going to have this error field here. And we can go ahead and save that. Oh, and then we also want to return, right? We don't want to redirect if you had an error. We want to let you stay on the page so you can fix your error and then resubmit it. Okay. So let's go ahead and try this out. Crap. So I'll come over here, I'll add volunteer, and I'll send some bad data. Boom. It failed to create the volunteer. We're telling the client about it. And now they can say, okay, I need to actually come in here and fix some of this, right? So I can add last name. And the cool thing is, you remember how we defined that an email should look like an email? If I come in here and say not an email, I can submit this and I'll still get an error message because it knows to check, hey, this email field should be an actual email. So I can actually fix this. And I can say a at good.email, and I'll say good. And if we submit this now, everything works. We can scroll down. There we go. We can scroll down to the bottom and we see our volunteer was actually created in the database. All right. So before moving on, let's recap what we just did. First, we created our types using Zod and then used those Zod types to create our TypeScript types. Then we use the Zod types safe parse method to ensure that the data we received, that our API endpoint received for creating a volunteer is correct. And then if it isn't, we send back an error and show that error to the user. All right. So that's awesome. However, there are a few problems. One, our error message doesn't really tell the user what's wrong. It just says, hey, try again. And then also, we have to actually hit submit and make the network request before we find out that the user is submitting bad data. But if you've ever been on a website, you'll know that most websites you visit will have some sort of form validation where they ensure all the data in the form is correct before sending it up to the API. This is also something we do at Hack for Impact. So let's take a look at how we can do this. Almost unsurprisingly, we also use Zod to enable our form validation. So, and to do this, we use a package that Hack for Impact wrote called use form validation. And to use this package, we first have to define a Zod type for our form. And I like to keep my stuff nice and organized. So I'm going to create a new folder in this types folder called form. So then in here, we will create a new file, and I'll just call that volunteer. And this is going to store all of our Zod types around volunteer forms. All right. So then our volunteer form is going to look pretty similar to our volunteer type. So I'll come in here, or I'll come into my volunteer, and I'm just going to copy this, to be honest with y'all. Let's go ahead and copy that, paste that in. And I am going to change the name. I'm going to call this Z volunteer form data. And then I'll need to import my Z. And I'm also going to do one more thing. I'm going to come into this .min function here, and I'm going to add another argument to it. The second argument in any of the Zod functions is an object that takes in a message. And that's the error message that you'll display to the user if validation fails, right? So I'll come in here and I'll say message required. All right, because the idea here is that if your string is less than 1 character, you don't actually have anything in that field, so it's not there. So we need to tell the user that it's required. And I'll come down here and do the same thing for this one. And I'll come down here and do the same thing for this one. And I'll come down here and do the same thing for this one. All right, and that's looking pretty good. There is one more thing I'm going to do, which I'll talk about a little later. But I'm going to move this email to over here and say z.string.email.main. All right, I'll talk about why I do that in a minute. Okay. Then I will use that special z.infer function to create my volunteer form data TypeScript type. And I'm going to say that's equal to z.infer type of z volunteer form data. And so now we have our Zod and TypeScript types. All right. So now we actually need to use these. So first, what we're going to do is we are going to go into our volunteer form component. So we have this volunteer form, and you'll see in a lot of places we're using the create volunteer request. We actually now have a type that specifically describes what should be in our forms. So we're going to actually just change all of these create volunteer requests to volunteer form data. Okay, and this is not going to like that, so then I'll save that and I'll auto import this. Okay. What's wrong with this? Oh, I also forgot to delete num events. We're not going to have a field for events, so we can delete that field. All right. And now that should be happy. Awesome. Okay. So again, this is because we have a dedicated type to what's being stored in the form. We don't have to kind of mash this request type into this dedicated type. And so we'll also go into our new volunteer view component. Whoops. We'll go into our new volunteer view component, and we'll also update all these types in here. And I'm going to, yeah, that one. Delete that and do my auto import magic. What? Okay. Sweet. Okay. So we've updated our state and our handle submit. Now these are all working with volunteer form data. Perfect. We're good to go. So next, while still in the new volunteer view, we are going to use this use form validation hook that comes from this package. And as a reminder, a hook is just a special React function. And this will give us back a function that we can then use to validate our data. So let's go ahead and do that. I'm going to say const validate. This is going to be the name of our function. Equals use form validation. What? Oh no, it's all going wrong. Use form validation. Save that. It's taking a minute, and let me see if I can auto import this. All right. I'm gonna stop the recording. Okay, so we've imported our use form validation from our package. And one thing that this function is expecting, this use form validation function here, is we need to give it the Zod type of our form. Okay, so I'll go ahead and pass in here Z volunteer form data. And if I save that, we now have this validate function. It's going to take in our form data, and then it's going to spit out this kind of errors field. And I'll talk about that in a second. So next, we're going to create a new state. So if you need a refresher on state, go back and watch the week 3 video on React. But this state is going to store our validation errors for the form. Okay. So we will go ahead and say const validation errors, set validation errors, equals use state. And then we actually need to say what this type of the state is going to be. And we are going to set that type to be something called validation errors. And then we need to say what kind of validation errors are going to be, or is this going to be? So we'll say this is going to be for our volunteer form data. Okay. And then we'll also say that this can be undefined, right? Because if there are no errors, they're not going to be defined. So that's all good. So we'll say or undefined. And we will give that a starting value of undefined. Okay. Cool. So let's quickly talk about this validation errors volunteer form data type and what that means. So let's go ahead and do an illustrative example again. Essentially, what this type is describing is it's describing an object that has all of the fields of our form data type, and then a string for whatever the error is going to be. Okay, so a good example would be like first name, required, email, invalid email. Okay, this would be an example of our validation errors for our form data. And one thing I want to point out here is that we don't have all the fields here, right? This is because maybe not all fields are going to have an error. Maybe just my first name and email fields have errors. So I don't actually want to put like last name or address in this object because they're not going to have errors. All right. Any questions about that type or anything we've done with this hook or anything like that? Okay. Sweet. So now we've got our validate function and we've got our validation error state. Let's go ahead and make the form validation work. So inside of this handle submit function, we're going to call the validate function before we actually make our request to create the volunteer. So I will first define a variable and I'll say const errors equals validate, and then we'll pass in our data. All right. Now, this function validate is either going to return that validation errors type if there are some validation errors, or it's going to return null if there are no validation errors. Okay. So all we have to do to actually set our validation errors and say, hey, there are some validation errors with this form. All we have to do is say, if there are any errors, set validation errors, and we'll set those to errors. Okay. We'll also return because again, we don't want to be making that call if there are errors. We just want to return so that we can tell the client about it and they can fix it. All right. Then finally, after they pass this, so if there are no validation errors, we're going to clear that. We're going to clear out any previous validation errors, right? So maybe I tried to submit, there were some validation errors. I addressed them. I submit again. We want to clear those out. All right. So we'll say set validation errors undefined. Okay. All right. Halfway done. Let's recap what we just did. First, we created the Zod type and TypeScript types for our form. Then we used the use form validation hook with the Zod type to get a function that will validate our form data and return any errors. And we created a state to store said errors. Then we call that function. And if there are any errors, we store them. And if there aren't, we clear out the previously stored errors. Okay. So this is great, but it actually won't show us any errors in our front end. In order for us to see the validation errors, we need to update our form, our volunteer form component. So first, we'll come into our volunteer form component and we'll add another prop to this component and we'll call that errors. This will be an optional prop because if there are no errors, that's fine. And we'll say, okay, this is going to be that validation result or validation errors. And this validation errors will be for our volunteer form data. Okay, so now we have a new prop on this. And again, that's going to look like field error. Okay. Next, we're going to use this prop. So I'll come in here and say, I actually want to use this prop. So we're going to say comma errors here. So we actually get a variable for our errors. Then inside of each of these text field components, which come from MUI, we are going to use this errors prop to determine if we should display an error message for each of the given text fields. Okay, so let's just do one of these examples. First, we will do the first name field. So there's two props we have to set on the text field to handle this. The first one is called error. This prop is a Boolean that's going to say, hey, is this field in an error state or not? Okay, so in order to set this, we need to say Boolean and then errors dot first name. Okay, so what this is saying is errors dot first name is either going to be undefined or a string. We want to change the undefined or a string into a Boolean, and we can do that with this Boolean function here, which is going to turn undefined into false and a string into true. Okay, so that's all we're doing. We're just turning this kind of non-Boolean into an actual Boolean. This question mark here is called the safe access operator. This is saying, hey, errors might actually be undefined. So if we try and say undefined dot first name, don't throw an error. Normally you would. Just give me back undefined. Okay, so that's why we have that question mark there. And then after we've done this, so now we know whether or not the form or the field is in an error state. Now we need to determine what we should show for like the error message. And so for doing that, we use this prop called helper text. And we will just set that one equal to errors dot first name. All right. Okay. So now all we need to do to make this work is come back into our new volunteer view and come down to where we put our volunteer form component here. And we just pass in errors, the errors prop, and this is going to be equal to validation errors. And I'll save that. I will run my dev server. Okay. I'm going to run my dev server. And if I go ahead and try and submit this, you'll see, boom, we get an error message. It's not even going to submit the form. It's saying, hey, this is required. I could go ahead and set this now. And since we didn't do anything for the front end for the other fields, it's not actually going to show us anything. I had some code. It says in my notes, copy and paste some code. I forgot to put that in there. So if you guys will bear with me for just 1 second, we can actually show this full example. And I actually am going to turn Copilot on for this because it's going to really help me speed this along. I'll start here. We'll do last name, then I'll come down to this one and watch this. Watch this. Boom and boom. Then I'll come down to this one. It should get the idea now. Nope. Okay. Error, get the idea. Bang. And then finally for our address, we'll do the same thing. Error. And that. Okay. And so now if I submit again, wait, did I not save this? Maybe I need to refresh the page. If I now submit again, you'll see all of our required fields saying, hey, this field is actually required, right? And the same example from before, if I say not an email, and I submit this, it's going to say, hey, invalid email. So this is how we do form validation. And this like email thing where we have the invalid email, but also required is the reason that I went ahead and changed how the ordering was on this Zod type for the email. The one it's going to prefer to use, is whichever one fails last, right? So when there's no email, right? When you don't have anything in the field, it's going to fail both the email check and the min check. It's only going to show the error message for the one that we have last, right? So if I had the email over here at the end, like I did before, and I submit this form again, refresh it and submit this form again, you'll see that instead of saying required, it says invalid email. So just because I would rather show them the required message if they don't fill anything out, I said, okay, let's put that before this one. Okay. Any questions about form validation, Zod types, anything like that? How you guys feeling about this? All right, cool. That's it. So just to quickly recap everything we talked about today. First, we looked at the most important kinds of status codes, 200 for, or 2xx for success, 4xx for error from the client, and 5xx for error from the server. Then we talked about why it's important to validate at the boundaries of our application. And then we implemented API and form validation using Zod and displayed any users to the error to create a better experience and a safer application. Okay? And that's it. This was actually our last workshop that will be teaching you guys stuff. Next week, we're still gonna have you come in. We're gonna do a recap of everything we went over this semester and get some feedback from you all about how we did and what we can do better next semester. Next week's meeting is the most important one for us because it lets us know what we did well and what we can improve on for the next batch of learners. So please attend. Let me stop the recording.